The Structural Engineering Podcast.
Welcome back to the Structural Engineering Podcast. This week, Max and I are sitting down for the 100th episode.
Oh
this
my
is
gosh.
This is a big one. We're super pumped about this. We asked our audience, you, to send in questions that we can answer. So get ready, sit back, and buckle in because it's going to be a lot of fun.
I'm excited. And this is going to be a much more casual episode. You know, we've got a great one recorded for 2 weeks from now, but celebrating our 100th year, we're pretty pumped about it. I can't believe that we've done 100 episodes.
Max, when we started this, think we'd make it to 100?
No. I don't know what I thought we'd make it to, but we've talked to a lot of people. It's so cool.
Yeah, I would agree with you there. When we started, I didn't even I fathom 100. I was like, this is something Max and I will start, and I'm sure it'll just eventually die off. But I'm glad that we're still doing this 7 years later. We started in 2018, which is wild.
Yeah, I'm still into it, and I can't believe it. But
do you remember why we started the podcast?
100. Why we started? Kind of. Go. Give me your version.
Okay, this is what I remember. It was 2018. We'd both couple years into our career, and we're studying for the PE exam. I listened to a book called Jab, 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 Right Hook by Gary Vee, and maybe a little podcast or two from him. And he was talking a lot about it's the best time ever right now to get into podcasting. Take any passion you have and build a podcast. And I remember at that same time, there's like this worry in the air. I wouldn't say it was anything that was written down as like perception, maybe like the economy was going to have some issues sometime soon. And, in the last 7 years,
I remember,
turns out all the time the economy is going to have issues. So, and we thought we're studying, man, we've learned all this information. How do we teach? How do more people learn this or hear about it? At the same time as start a podcast. Well, that'd be kind of cool. We could interview people. We could do episodes on different topics so people could just learn about structural engineering via audio. Remember that discussion? And then it was also, how could we differentiate ourselves from others? Well, Max and Zach have a podcast. That could be cool. People might like that. Firms, if we ever needed to find another job, they might think that's kind of cool. Okay. Maybe we don't lose our jobs during a bad economy for having a podcast. Well, this last 7 years, economy hasn't had the challenges maybe we thought, but I think it's been really cool being able to interview so many people. And something that surprised me, Max, in the last 7 years is the opportunity to interview people. Pretty much everyone we've wanted to talk to has said yes, and I think that has been really cool. It's just we're two random guys.
Yeah, my big takeaway from that is just ask the question if you have it. I think maybe 3 or 4 people have said no out of 100. Those are pretty good odds.
Yeah. Over the last 7 years, Max, what's your biggest highlight? What's your favorite episode? What do you remember the most?
My biggest one actually is, and we didn't even get an episode out of it. We did an episode with Core Brace. We toured Core Brace in Utah, their facility. It was amazing. We had lunch with the guys. It was the best. And this was early on in our learning this stuff. And we botched the recording. It, I don't know, it saved over something, or it didn't save correctly. This was a while ago. And we lost our first big episode with, a technical group that was skilled and they really liked what they were doing, and we had a great conversation, and who knows where that is.
Man, I agree with you there. That was a big miss. We learned the information but weren't able to share it.
Yeah. What do you have?
I would say our first, I don't even know if I can point to a single one. I have learned so much through doing this podcast professionally, but the times that I remember that were, I would say, enjoyable and exciting were those first maybe 10 episodes we did. The first 5 or so are on YouTube. And it was like we just started. We're at my house in the little office I had. We had a table set up. We put the most random things in the room. and we just hit record. Yeah, why not? And they're just, I still like to, like, they're very cringy to watch the videos on YouTube, but they're just fun. Like one of them, we're dressed up for Christmas.
Oh, really?
And it had nothing to do about the episode. We just decided to dress up festively. I think those were fun. Like we just had no clue what we're doing. We had way less responsibility in our lives. And we were just having a good time, sharing a beer and podcasting. It was pretty good times.
I like that one. I think that's very good.
All right, Max. So the first question that we got asked, I want to just jump into this. Give us your background. How did you go? Start wherever you want to start and get to where you are today. Just give a background for the audience of who you are.
I have a bumpy sort of road to get to structural engineering. So I went to my undergrad was in architecture. I knew by the end of architecture that it just wasn't what I wanted to do, and I wasn't going to be skilled in the creative sense of an architect. I can be creative, but I just wasn't fitting the category of architecture. But I was 2 years in before I was thinking about this, and I didn't really want to change my majors. So I graduated as an architect. Just the undergrad. Architects need a master's to have a license, and so I could have done a plus 1 year to be a licensed architect, but I worked in a firm for 6 months, and then I moved to. I said this is not what I want to do, and I'm 22. I'll figure it out. Bought a Jeep that could only go 60 miles an hour. Drove on Highway 36. So I can go 60 miles to Colorado. I went to the Colorado Mountain College. Had an engineering program that would transfer to CU and to the college here. Got some credits and got started on the master's, like in this weird bumpy path that I basically did engineering work from the get-go. Like I had an internship with the architecture degree. So I was able to do very fundamental engineering, but just learn more and more, and pretty much worked full time through. I did get another undergrad, but only on like the way to master's, kind of adjacent, and then master's, and in this big circle, many firms, and landed in Utah. So I'll land, who knows, but I'm in Utah.
What about the things you like to do?
What are the projects I like to do?
No, personal things. What hobbies do you have, Max?
Oh gosh. God, do I like anything?
It's got to be more instructional.
I like doing the we do this podcast. I like. I like skiing and running, and those are the big ones. Yeah, as much as possible. Cooking also. Let's do that one. All right.
Okay.
Zach, what do you got? How did you get here?
Okay, so in the early 90s, I was born. No, I'm just joking. I don't know how far back you want me to go. So actually, around 11 years old, I got into road cycling and found a group of guys in their 30s that were racing and would mentor me. And one of those guys worked at a civil engineering firm in the area and ended up being the president and CEO of the firm years later. And kind of all of his buddies that he biked with were in the same AEC kind of world to some extent. And I just remember going on long rides on the weekends with them, and in evenings in the summers, either going to bike races or, just going around town. And that's like all they talked about and overheard, so frequently. And I just remember asking so many questions. The one that sits with me a lot was like, why does the railroad get the right of way instead of vehicles? And how did that come to? I have no clue at the time where that came to mind, but it's something that sits in my mind of that time that I remember. And so I was trying to figure out in high school what I wanted to do. At that point, it was just all about bike racing. And this guy was like, you should be a civil engineer. I said, okay, that sounds interesting. That's all I hear you talk about. That sounds cool. So I ended up going to college for civil engineering, and found that when I was there, took a class on kind of all the different types of civil engineering, found traffic to be boring and environmental to not be as interesting. And maybe environmental is too smart for me. And chemicals don't sound like a fun thing to be focused on every day. And anyways, found structural to be it, and got a degree in structural engineering. And then, right out of school, worked at a firm doing high seismic and timber type stuff. Moved to Colorado, where I eventually met you, and still here in Colorado. So that's been pretty cool. Yeah, throughout that time, cycling was a big part. Running's now a big part of my life.
You got me beat on the running pretty serious now.
All the Colorado things, fishing, hiking, trail running. So yeah, that's say kind of my career journey and where I am now.
Yeah, I guess we actually do mostly the same stuff. You're a real road biker. That's the only activity that I don't do that you do. They're like, yeah.
Used to do.
Oh yeah, and skiing.
I got burnt out.
Yeah, hey.
You're a real skier. I dabble in skiing.
Yeah, those are our two switches that you don't really ski. I don't really bike.
Yeah. Yep. Okay, so jumping into some more questions. What is one structural code change you believe is long overdue and why? Can't wait to hear your answer.
Getting into a serious one here. I don't actually have I don't know if I have a code change. One thing I would like to see updated is performance-based. I was just talking to an old colleague actually earlier today that focuses on performance-based design, pushover analysis, and he will be on the podcast in the spring. I think it'd be interesting to see that a little more codified, or a few more sections of code that lean towards what the intent is without the prescriptive, do this, this is the exact loading in this case. This is how your seismic load travels up. Like in this computer world, we've got the exact mass fully all the way up the building. We have a BIM model of this building. I think we can just get a little bit more refined with the analysis. It's good to still have this backdrop because we don't know what things will look like in the future, but as far as building occupancy, but we can paint pretty nice pictures now of what the loads are going to be and do some more serious analysis of how they're going to transfer through the building. So that is one that I have. I have a couple. I'll keep thinking, but do you have one? And we'll kind of bounce back and forth.
I think the one that comes to mind, and something you and I have talked about over the years, is how to make code simpler. And that's really the one code change I think would be great is ASC 7, although a fantastic document that we all utilize. It seems that probably majority of structural engineers use maybe half of it, and that might be pushing it. So I think like some simplified version of ASC 7 would be fantastic. I mean, there's so many different wind options, or there's two main wind options, but and that you get in the seismic section and it just keeps going and going. And I think for what majority of people utilize it for, I think there could be a simplified version of ASC 7, and I think that would help.
Have you ever used the simplified seismic design? It's in chapter 12, but it's kind of the end.
No, every time I get into chapter 12, I look at it and I'm like,
yeah, neither have I.
I think I should figure out using this, but I just I know exactly my regular route of design and I'm just going to keep to it. But that's one thing that came to mind too, is that section, or tsunami loading, or, there's definitely people that have to use it, but even on coastal projects, like I'm pretty sure you only need it has to be a category 4 building to require it. So don't quote me on that. That's just off the top of my mind. So I think a simplified code. I also wonder, and this is for sure for a future podcast episode, and I really want to dive into this one, is like, how much error do we create in our designs because of the complexity that has been added? I mean, I hear people all the time joke that to do wind loading, or, depending what procedure you use, you might need a master's class just in wind loading. Where the UBC was like, let's say 35 PSF everywhere. And you're just done and you're good. And I'm curious if if being as precise as we're trying to be with changing the pressure as the building gets taller is worth it. I would love to talk to somebody about this, like the trade-offs.
Who a professional that we can talk to about this, because I think I lean the other direction a little bit, that like we can be what I was just saying, we can be more detailed, more specific with loading. Why don't we? But there is also the UBC worked perfectly fine. I don't know what the balance is.
I'm curious on the cost as well. if you, instead of, 35, it can be 30, is that really saving costs because of the basis of what engineers would probably provide anyways? Anyways, that's for another time. But that's what I think about with this question is I think we should make engineering more simple. And can we make the code more simple? And then let's say an engineer wants to take it to another level or is required to for some reason. Then there's a more in-depth section. But yeah, I'm not going to have.
I thought of one other that would be nice to see, and this is actually as a code change a little more, is a more uniform approach to existing buildings, and maybe not uniform, but a clear path for the IEBC, International Existing Building Code. You have your 5% added gravity loads, which, I'm sure there's a great commentary on why this can exist. But it just seems a little squishy on how you approach these things in like your 10% lateral. Why are those different? Again, I'm sure the commentary, and I guess I do have some ideas here, but I think we have so many buildings, existing buildings. We should have a little more robust analysis to us of, material properties by year. What was, when did steel go from 36 to 50? I think was that 2001, 97. Just if anyone asks, 1997. But I think there will be a point where that is just common knowledge, and we can design with that intent. Like, look at the shapes and not do this 5-10% additional, just kind of blanket. I'd like to see a little more detail there. So I'm again leaning on the detail. Give me.
All right, Max. Next one here. If you could join the design team for any building in history or currently under construction, which one would it be?
So my biggest one would be Sydney Opera House. I have Ove Arup's books. Peter Rice, I'm wrong again. An Engineer Imagines is an amazing book for an architect and an engineer, but it's such a wonderful read, and it's a great explanation of engineering logic. Ove Arup also has a book, but Peter Rice is my real go-to. I think that was just really pushing like the analysis capability, and then he was on site the entire time. So it was a real interesting gap of like we were able to do these complex analysis, but the engineer was still on site always. I think I remember in one of the books is like he would measure where the concrete needed to be poured at what elevation of this curve every day. And so then they would go do it. They're completely an active participant in the construction, right? We're in this world now where you just send out these drawings and like 2 years later you hear that they finished, or like you get invited to the last steel placement or something. I think Sydney Opera House was a really cool mesh of super capable, but still very involved. So that's what I got. What do you think?
That came to my top 5 100%. I mean,
oh well, no, I claimed it. So give me your
so
number 2.
I'm leaving that alone. It took me a while to think about this, and I have an answer that's silly, but is truly honest, and I think that would be one of the Great Pyramids. I think have been so fascinating back in the time. I think in addition to that, the Rome Colosseum, more recent, the Eiffel Tower, and even more recent, the Burj Khalifa. Just being part of such substantial projects would be so cool. But I think that, and we've talked about it before, the construction and maybe design, I don't know, of the pyramids would be absolutely astronomical and wild and so cool. So I'm just gonna leave it with that. And
yeah, I think I'm gonna agree on all of those, but pyramid, yeah, that's some serious problem solving that we don't even know how they did it, and like
I want to know
an engineer figured out how to move stone,
and so the fit up is so precise, and there's stones that weigh 50 tons or more. Like what?
Yeah,
it'd be a substantial, if not one of the largest construction, projects to do today to build it. So pretty wild. All right, quick one for you, Max. If you started your own engineering firm, what would you call it? Funny answers only, as the question was asked.
A moment for beams.
I like that.
That's all I can get. What do you got? What do you got?
Mine was Beam Me Up LLC.
Yours is better, damn.
All right.
Something like
That was a good one.
Sheer. Sheer. Oh, I'm gonna go with Sheer Bliss LLC.
Okay.
Look for it to open soon.
So those last couple of questions, 3 or 4 questions, were submitted when we had no name. So this one comes from Colin. He says to talk about the mistakes you guys have made in engineering and in general.
How long do we have?
I'd say in general, I hope it's just engineering because life is all about mistakes and learning from them. So,
yeah.
You want to get started? Or you want me to start on this one, Max?
Why don't I get started? I got some good ones. So I think early on, a firm I was with didn't do the greatest thorough projects, and they were starting just a few people. I was the first structural, and they had eventually grown to 4 structural, 4 civil by this time, and a senior structural had been hired. And I definitely used to run on the impression that the senior engineer, they got it. There's no issue here. Like, they're the last person that needs to organize everything, and if I just do the task they ask, that's my job. I don't need to think about the big picture. We had a foundation placement that, well, we didn't have a placement. The senior engineer asked me to put a foundation. Here are the dimensions, and it was kind of a quick job. It ended up being in the wrong place. The senior engineer had just given me the loading and do it this wide and this spacing between them, and I kicked out the drawing quickly, and it was like a 10-foot gap, 20-foot between these walls, and a 16-inch wide. It wasn't holding that much. The team poured it, and then the client said, "This is in the wrong place." And then this got very complicated because did I make the mistake? Did the senior engineer make the mistake? Did the owner of this firm that checked the drawings, did they make the mistake? And it was really like a mix of communication that was just not how firms should interact, and not how engineers should go about problems, right? Like, I took from this, like, you should have a full grasp of the project. And when you're very young, this is not going to happen. But after a couple of years, and if you don't know something, you should ask for a direct answer, right? Like, there was real communication issues in this, and it cost the firm quite a bit. And I left to another place immediately. That was tough, and no real who did what wrong, right? Like, I have my version, but this was just a communication thing that we all failed so miserably. And so that was my biggest miss in engineering, is a foundation that was a foot away from where it was supposed to be, and no one knew who had made the mistake and who was going to pay for it. What do you think of that one? And what do you got?
Yeah, I feel like that one happens probably a lot out in the world. I think miscommunication occurs a lot. I think there's a lot of people that probably think that what was discussed or reviewed was just right, almost too.
Yep.
Or something like as specific as that probably should just be discussed with the owner, and anything that's really particular, especially something else that's just maybe interface with it that is not something you're providing, that's client owner supplied. I bet it happens more often than you think.
Yeah.
I think if that was one of your biggest mess ups ever in your career, Max, pretty good.
Really?
Good.
Oh man, no, that's one keeps me off awake at night. Just okay. What kind of? I want to hear what you have, and so I'll compare mine against yours and see if I feel bad anymore.
I think one of my biggest mistakes professionally, more so, was at the beginning of my career. I mean, I have a very long career to still go, but was at the beginning of my career thinking I knew what I was doing. So confidently knew, and just repeatedly with QCs where shit was shown that I was wrong or I missed something. And the first 2 years of my career, I worked for a firm that did high seismic and timber and mass timber, and I just remember being so confident in what I was doing and excited, and then I'd have a senior engineer review it, and they would be like, "No, these things are wrong." So is that learning piece? And I think what I learned from that is humility, and being able to be humble and to not have that ego is such an important like thing in what we do. Right? We protect humanity. We keep buildings up to keep people safe, and so that was, I would say, one of the items that I did not do good at and I think was a mistake. Not direct engineering per se, but the first week of my career was spent only designing a few beams, Max.
But you did them very well, right? I'm sure you thought they were like.
I designed it over and over and over again.
Did you think they were perfect, or were you like, I can design beams, I'm an engineer? Or you're like, why did you already know, why did this take me so long?
Yeah, that one. Why did this take me so long? I designed a glue lam beam. I remember it was for this deck on this house. It's big house. And
was this Enercalc or was this hand calc?
It was first hand calc. And their philosophy, which I still live to this day, is if you don't know how to do the hand calc, always do the hand calc. And then once you know it, use the computer for the efficiency and repetitiveness. So did it by hand, it was wrong. Did it again by hand, it was wrong. I had the species wrong. I had the width wrong. And then I had it checked for strength, but I didn't check it for deflection. And at the time I was a little frustrated because the principal kept just telling me I was wrong on one item and go fix it. And I was like, give me all the 5 items. But I realized it was really important that we're iterating the next problem and then the next problem, the next one. It was something that's sat with me. And, when I onboard new engineers, I always try to explain to them this story. It's like, I thought I knew what I was doing. I'd never taken a wood class before, so I had no clue about glue lam beams and the grades of them. And they kind of just said, "Hey, go design this beam. Here's a loading." And then we used another program, and I thought I was trying to be fancy with it. And there's joists at 16 inches on center, excuse me. And instead, Max, of putting a line load on this girder, this glue lam, I point loaded every 16 inches, thinking that would make me the most efficient with my design.
Yeah.
And I'm sure you remember that engineering class where it talks about smearing the load, like how close do the point loads need to be together once it's just PLF, and it doesn't matter as much. And 16-inch on center is plenty close.
That's pretty smeared.
And so
I remember, do you actually, is this a real code thing or is it just in my head, that at what point how many loads can you put it to till you have to put it to a uniform load? It's like past 3 point loads and even spacing, it's a uniform load. But, this is not a steadfast. If you have 3 point loads that are 20 feet apart, that is not a uniform. I just had this in my head that I learned at some point.
Yeah, I don't remember where, but it's kind of intuitive now for the most part.
Okay, I want to prompt the next question here. This is also from Colin. I really like this question. What resources do you find most useful to grow your engineering knowledge? Let's lead us off.
I think a lot of my career has been spent asking questions or finding answers to questions that seems like not only have I've had, but everyone else on Eng tips, and not necessarily for the answer, but directing me to where it is in the code. I think that was one of the most useful things, because half the time you're just trying to figure out where it is and where does that code section live. You know what I mean?
Yeah.
And so I think it's, I don't know, very useful in that manner. So that was a resource. I found now that an equivalent to that, which also searches it, is AI. Copilot, ChatGPT often references it. And so asking AI the question then kind of gets me there with the code, or even better, it usually just directs me straight to the code. So as I've developed through my career, and as technology has developed, AI has become more valuable. And then the other resource I would say is just finding a really good mentor. That has probably been the biggest thing that's helped me through my career. At each stage of it is a good mentor that's there to spend the time. As more senior people get busier with different things they're doing, contracts with clients, they're usually handling the bigger problems within the firm to some extent. Someone to take the time to spend with you to help you become a better engineer and talk through stuff has probably been the best resource, truly, in my career. And those people, whether I work with them or not, I stay in contact with them. So, Max, what about you? What resources have you found?
I got a lot. I think the biggest theme is asking questions, right? And I think that carries through on our answers on a lot of these things. It is why we have a podcast. But in that sort of format, like Structure Magazine, I'm not asking Structure Mag questions, but reading that every month, that is the engineers that want to tell the story of the thing that they developed, the logic that went into it, how they made this creative structure. And I can really take a lot from that, and I think everyone can. So that's definitely a big one. Peer reviews, red lines from senior engineers. That was a position early in my career that someone, like you're mentioning, someone really redlined some stuff up. Like, that's how you take what the answer should be and what the logic path should be, right? There are many things that you don't need to think about deeply if you're just sizing a beam for bending, right? It's just like that. You're not going to get a red line on sizing a beam for bending, but it is, how do you put this building together? What is the construction sequence? What do you need to be worried about in some cases? Yeah. So I took a lot from red lines and the older engineers when I was a young guy. I got a bunch on this one. I think teaching, presenting, right? This podcast, of course, but also I've done some talks at school, colleges, and just getting to talk about the profession that I really enjoy and talk about projects. The more it just reinforces the concepts in my head when I have to bring them up to somebody else. And the obvious one to me here, the app that we just made. Do you want to? I've been talking for a while here. Do you want to kick off on the app thing? I'll throw in some comments.
Yeah, for sure. So, we're tossing out the idea of studying for the PE and SE has a lot of cost behind it. A lot of the courses are pretty expensive, but what can we do to develop something that's community based, since we have a community with the podcast, and develop Structured. It's an app on our website, theengineeringpodcast.com. It's completely free. Max and I put a lot of questions in there for all different materials, all different codes, and it's all community based. So you can submit your own questions. Max and I will review them and get them, published, just making sure the formatting's good. And we kind of want to double check the questions and the answers people are submitting on there. But so far it's been great. We've gotten a lot of good feedback. A lot of people have signed up for it. You go on there, you make an account. You can set up how you want the questions. There's quizzes, note cards. It tells you how you're doing versus the rest of the community. And then you can kind of track your progress on there. It's been pretty cool, Max. I've enjoyed even doing it.
Yeah, absolutely. Me too. And I'm going to, while we have the moment to pitch this thing, I want to say, give us a month. I think this is so cool and could be a really great way to spread information in our structural community here, but I don't think it's excellent right now. I think it's pretty good. It's okay, but we're going to keep making these updates, and we need your input. If you see something that's wrong, that's why I was talking with my other friend, he had caught something and he just gave me a call, email. I mean, I think we can build this really cool thing, and it will, like you said, it's free. It will always be free, right? It's just, this can be an in-place resource that everyone can generate, and it will just exist in this website.
Yeah, please give us feedback. It's the only way we can make it better. We're super excited to keep developing it. I think there's some more add-ons that we have thoughts for that will be in the future. We want it to be in a really good place before we add any more things to it. But yeah, I think it's a great resource from a study perspective. All right, Max. Next question from David. Is it possible to do an episode featuring a writer from Structure Mag or AISC magazine? What do you think?
David, what's up? Yes, of course it is. We have.
Perfect.
And when we'll do much more. So I didn't answer on the last question, but I do some committee work for NCSCA, and this ties into Structure Magazine, and I really love it. So in the weird, complicated way, do this very lightly. But yeah, we have one coming up soon. We had one. His name is escaping me right now.
His name
Scott
is John.
Johnson. Wasn't he a Structure Mag?
No,
No, he was Modern Steel.
No, neither.
Yeah, the Alice Tube connections of the Mr. Beast Trust.
Oh, Scott Collins.
Oh, Scott Collins. Gosh, yeah. Sorry.
Him, and then there was
We've done
John.
100 of these.
Yeah. Yeah, there's been a couple people, but for sure we're gonna do more. There's no doubt. Steven asked, what is your biggest aha moment? What do you got for us, Max?
I think this is the harder one. I probably a lot of little. I couldn't think of a big aha. The biggest thing that I am falling back on now, 15 years in this, is load follows stiffness, and especially when I'm doing more industrial style structures now, where it's not a clear load path, joist to girder, and down to columns. You're tracking the stiffness always to make sure there's no load isn't sneaking some way that is going to force transfer around a connection that wasn't designed for this. And so that is my biggest aha moment in a sense is, however you think this is going to go, make sure to step back and say, what is the stiffness of the structure? And as it moves in a windstorm, an earthquake, like where is the load going to go and want to follow to get to the stiffest path foundation? That's it. What do you got, Zach?
Gosh, there's a lot of aha moments, a lot of late nights working on projects that, okay, we can make that work. Couple things that jump out to me. Wind, the deflection requirements under wind loading for your whole building, your main wind force, is not a codified thing. And I watched a webinar early in my career by Emily Guglielmo about just deflections in general, which was fantastic. And had an aha moment of there is a code section. It's in the commentary of ASC 7 that talks about deflections of things, and it talks about for wind, main wind force, that you could look at potentially a 10-year MRI to develop what that wind pressure would be. And I found that to be interesting and make a lot of sense. And I was like, oh, okay, this is great. And to the same light, in seismic, the C sub D factor, I think I remember an aha moment early in my career where it was like, why do we need this? This doesn't make sense. And once you learn about what it's there for, which it's very close to your R factor, response modification, for that reason, we're lowering the loads to design for ductility, but we're actually going back up to the full force because that's how we're going to check it to move. So I found those two moments early in my career more ahas. And then, so many different things from different types of welding. And again, these are late night working on projects and trying to solve problems and challenges.
I do have a welder you can borrow if you need. If that'll help.
That might help. You just start welding while working on things. So yeah. And then, I would say again, a big just career aha was we can only really be successful if we all do it together. And the technical side is only one part of all of this. It's the communication with the clients, with your colleagues, with unfortunately the mechanical engineer that just pokes holes in everything. But for us to deliver a really good building, you got to build these relationships. We had a great episode a while ago talking about this. We thought we were sitting down with Robert to talk about mass timber, and what he wanted to talk about was his passion about building relationships with architects. And the only way you can do good projects and successful projects is that you have a relationship with an architect. And this has really sat with me, like that you can have disagreements, you can argue on your way, in both directions, but you're very respectful, and you can kind of see the other person's, direction and why they want to get there and work together. And I thought that was really cool. That symbiotic relationship between structural engineers and architects are just so important. And I think it goes through working together. I think with other structural engineers, I think it works through with mechanical, as I mentioned, civil engineers. Like, build good relationships and you will find projects to prosper, because not only will you be able to communicate and have better discussions during design, but inevitably in construction, when things aren't going well, they'll still want to chat with you. You've built this great relationship on not just good things, but bad things. So I think that was more of a professional aha moment in my career.
Okay. Pretty good one.
All right. So Will asks, do you ever think about leaving structural engineering?
I had a hard path to get here. Not
yes
really.
Or
no? No. Yeah. I'm going to say not really was even like a light way. I thought about how to change my career in structural engineering, but not leaving structural engineering ever. So I'm happy with the version that I landed with. So I don't think I want to change anytime soon. What do you got, Zach?
As of right now, absolutely not. No way. Earlier in my career, year 2, 3, I definitely felt that maybe this wasn't for me. And I think when it was at the time you and I dove into this podcast, I told myself, let's give it everything we got, and let's see if this is it. And I did that, and this was it. And I found that to be a litmus test throughout my life of different things. Like, I don't know if I like this. Okay, I'm going to try doing it really hard and all in and see if I like it. And structural engineering is one thing I really liked. And I am so happy to go to work and enjoy everything I do every single day, and found the career that I really truly want the rest of my life.
Absolutely. I bet this question was asked so on the NCSEA SE3 committee, they have the survey on, it goes from salary and enjoyment. It's like every piece of your career. And
right.
I remember there was a lot of people that had considered leaving the career, and I can't remember what the number was, but it was like 70%, I'm pretty sure. Do you have any memory of this?
I think it was pretty high. And I think it's hard because it's a broad question. And I mean, doesn't almost everything you try or chase in life, you think at one point, maybe it's not for me? That's where I don't know.
Yeah. Hard to define. Like, yep.
Right. Okay. So in conjunction with that.
Hold on 1 sec. I looked it up while we're doing this. 59%.
Okay.
Close.
Okay. In conjunction to that last question, if you weren't a structural engineer, what would you be? What would you what else would you have wanted to be?
Well, I thought I wanted to be an architect. But I said, like, I wasn't good at it. That is absolutely true, but it also maybe wasn't what I should have been going after. I have a weird enjoyment of economics. And when I was young, I wanted to be an auto mechanic. So that's broadish. I even worked in a mechanic shop and considered not going to college and just becoming an auto mechanic. Would have been cool. So an auto mechanic or an economist.
And you landed in the middle of both of those by being a structural engineer.
Yeah, well, what do you got?
From a young age, I think being a road cyclist and racing. I wanted to be a professional cyclist. Watching the tour every year, I thought it was like the coolest thing that could ever be. And then in high school, while I was figuring out if I wanted to go to college, I was really just focused on, again, bike racing was my whole life. I thought we got 3 options. 1, we could be bike racer. 2, we could go to engineering school. 3, we could be a firefighter. Couldn't tell you where the motivation of that one or where that idea came from. It's not anything that I have relatives or friends or anyone that does that. But I thought being able to give back to a community and be there to protect the community would be really cool. So, yeah, those were the couple.
Those are good ones. I like them.
All right. Kyle asked, he says, almost graduated. When and how do I prep for the PE exam?
I'm going to say if you're interested enough in engineering to be listening to this podcast, you're prepping. Whatever prepping you're doing is going to be sufficient. I would get the SERM, Structural Engineering Reference Manual. That was what I studied on. Whatever. Hey, and you had said we were both studying for the SC when we started this. I think PE was 2015 or 16. I already had it. Yeah. Anyway, SERM. That is all the answers are in there.
Okay. Yeah, I would say this is all of our new hires. This is what I tell them: spend the first year building up, and this kind of answers maybe a little bit of the next question, but we'll talk about that too. That first year, build up doing everything by hand, every calculation you're doing, build that consistency of learning. If you can do it by hand, get it in the memory, the PE exam is only going to become that much easier. Then move into the tools after a year or two of doing that and building that up. I think, obviously listening to the podcast can help. I think more as a career thing. And then structure that we just created and talked about with flashcards and quizzes, I think will be able to help a lot. And writing questions for the app can really help. If you can write the question, you probably know it pretty well. So I'll say, because I know you're too humble to say, Max only studied for maybe 20 or 30 hours and took the PE and passed. I studied for 200 to 300 hours to take the PE and pass. So I think taking the exam and passing it is such a personal thing. But sitting down, probably figuring out what you need to study, what pieces of the exam, because Max, when you and I took it, the PE civil structural had a lot of civil things on it. And now it's mostly structural. So it's a little bit different than when we took it. But I think, being able to, obviously, a lot of memorization, learning the reference guide are all good things too. But I think really just starting off your career with a good mentor that pushes and helps you with hand calculations and will sit down when let's say you run it on the computer and they're just both totally different. What do? You go to that person you trust and can walk through it with you and help you. So, to me, that's how you prep. The next question and our last one here is from Brennan. He says, thoughts on how to successfully set yourself up to become a good structural engineer, starting with college, then your first 4 years, pre-PE, and then after your PE up to 8 to 10 years. What are your thoughts, Max?
I haven't figured it out yet. What do you have as an answer?
I think curiosity is got to be a big piece of this. I don't think there's a single way to set yourself up for success. Every firm is different. Every project you're on is different. Every region, country, continent, everyone is a bit different. I think being humble, not having ego, and just being curious, and all 3 of those stages will set you up for success. Helping others, college doesn't really teach you what we actually do on a day-to-day basis. I mean, when was the last time, like you said, like a bending check on a beam, like that you just did that by hand? it's not just a common thing we do. There's more automation, and the more senior you become in your firm, it's more you're reviewing documents to make sure everything appears correct to the most part. These sizes, I've done this so many times, a 30 by 30 bay. Do these sizes seem appropriate for a roof structure or a composite floor structure? Have we talked about and reviewed vibrations? And I think the further you get into it, things just change. So I think curiosity, and then learning, that's college in the first 4 years. And then I think you get your PE, you start becoming more comfortable. Truly, I think the first 4 to 5 years is the hardest part of your career. There's a little confident boost when you get your PE, more responsibility, which makes you really think about things maybe just a little bit more than you were totally thinking about, which probably doesn't change much of anything. But yeah, it's kind of what I would think would be what would help drive your success. Learn the business side of things. Firms are for-profit businesses for majority of them. So learn how to be efficient with what you do and how the business works, the sales process, billing, all those things. Just how can you provide value, and just asking questions. That's what I think, Max. What's your last tidbits there?
My last thought, Zach, I think, as you mentioned many times, curiosity, but also if you're enjoying your career, if you like talking about structural engineering and you enjoy learning things about it, you're going to be fine in your career. Honestly, the interest in this counts for so much, and you hold stuff in your head easier. Like, this isn't what you do for 8 hours and then thank God it's 5 o'clock and you can go home. I think a lot of people that get into structural engineering do because they really enjoy it. And the more you enjoy it, the easier it's going to be.
All right, Max, to wrap us up, I want you to ask me one question and I'm going to ask you one question. What do you got for me?
Both of us we got plenty of career left, a lot of it. What do you want your career to be in 20 years?
Wow, what a question.
How old will you be?
In 20 years, I'll be 53 years old. What I hope and wish for is a career of which I've built really strong relationships with both other internal engineers, but something that I saw early in my career was the owner of the firm I worked for, my first job out of school, was that he was friends with all the other leaders of all the firms. And if they ever ran into problems, they would call each other. Have you ever seen this? Hey, how would you solve this problem? And at the start of the day, you're competitors, but once you win the project, you're colleagues because you want to better structural engineering. And I've always thought that's the coolest thing. So I hope in 20 years that I've created those relationships and fostered those relationships to lead to that. I think that'd be really cool to be on committees with fellow engineers to build these relationships to provide more value to the engineering community. Yeah, I think that's where I'd want to be in 20 years, Max.
I like it.
My question to you is, if you could interview anybody or have a podcast about any topic for the Structural Engineering Podcast, who and or what would that be about?
Keep in mind my architectural beginnings, and the first book I reference, so the Sydney Opera House, Ova Arup, that would be a cool one. And Buckminster Fuller, when I was an architect, the clear path, it was clear to me that I should be a structural engineer because he was the perfect version of like a architect engineer. I guess he is an architect and an engineer. He like did some school. I don't know if he actually graduated from anything, but I think he did some architecture school, some engineering school. And so when I was in architecture, I read a lot about him, and just his really creative way to solve engineering problems. I think he was the epitome of like engineering done very well, not I mean, in the time period, not as technical as today, but like very problem solving, geometric based math. He was very impressive. So that's who I'd want to talk to.
Well, thank you to everyone that submitted questions. Max, I think we should do this more often. Maybe not once a month, but maybe once a year. I think it's a pretty cool.
See, at 200 episodes, man, we'll be there in no time.
Easily, especially in this next year. Max and I have a lot of motivations.
Yeah.
We're going to do 100 in the next year. No, for definitely not. But yeah, really, that's it for today's episode of the Structural Engineering Podcast. Big thanks to everyone that submitted questions and to really all of you for listening to the podcast. Max and I wouldn't be here doing it without you. So sincerely, thank you for participating. Also, remember, Structured is the new app that Max and I developed on the engineeringpodcast.com. Go there, check it out. And we're excited to come out with a new episode in 2 weeks. Stay tuned.
Close.